Hey there again, pre-calc students. This is Mrs. Weihe speaking once again. It's going to be my round 2 at trying this flip video. So here, this time we're going to be talking about quadratics for this lesson. Now, once again, we want to think about some things that we want to remember. So here are some terms that we'll kind of be discussing throughout this lesson. We'll talk about completing the square. That sometimes is a little bit of a doozy for students, so we'll spend some time really kind of going through that, and we'll encounter more of that inside the classroom when we do our peer reviews and on your assignment card. We'll also talk about the quadratic formula, which you guys are probably have heard once or twice before, but maybe not have worked with it that much. We'll also talk about the discriminant and maybe even venture off into conjugates just a little bit. Now, there are four different ways to solve quadratic equations. The first one is graphing, the second is factoring, the third is completing the square, and the fourth is using a quadratic formula. So we're going to go through some examples here of solving a quadratic equation by these different four techniques. Now first, we probably should talk about and discuss really what is a quadratic. Now, you guys have learned, I know previously here throughout this class time so far, about quadratic equations. Now remember, those are polynomial equations with a degree of 2. So this would be, an example would be like an x squared minus 4x plus 4. Now when we graph these, this is what gives us our horseshoe shape or that U shape. So I know we worked a little bit with graphing some of these before, but we're going to try different algebraic techniques here and just different methods for solving equations like these. So moving on to our first technique would be solving by graphing. Now the way we can solve by graphing is finding the solution, which is actually where the graph crosses the x-axis. So here when we're going to look at this example of x squared minus 6x minus 16. Now if we plug that into our graphing calculators a little bit here, we're going to actually see that it crosses our x-axis right here at -2, and I know we don't have a -8 over here on our board, but that should be right about here on this little graph here on our video. And we can kind of just fill this in just a little bit and this is just a rough drawing of what this graph actually would look like. So here our solutions for this is where that once again crosses the x-axis. So here our solution would be when x equals -2 and when x equals 8. Really quick, simple method of one way of finding a solution to these quadratic equations. Now moving on to our second way of solving is by factoring. And we talked briefly about this in our previous 4-1 lesson. Here we're going to kind of do the same thing, working with factoring. So kind of doing that reverse of FOIL. So here we want to figure out how we can multiply two quantities. So here we want to kind of take our x's in there right away. We want to figure out what kind of integers eventually when we kind of figure this out and solve would give us a -6x and also a -16. Now after we do that and kind of maybe tinker a little bit here, we can actually get x plus 2 and an x minus 8. And we set that quantity equal to 0. Now notice you can also kind of check by actually foiling. Just to make sure that you kind of got your same thing. That's a great way for you to check your work and make sure you're doing the correct steps. Now, just like how we did in the 4-1 lesson, we want to set each factor equal to 0, itself equal to 0. So we're going to set x plus 2 equal to 0 and x minus 8 equal to 0. We want to solve for x in both cases. Subtract 2 to each side. We should get x equals a -2. Over here, working with our x minus 8 equals 0, we want to add 8 to both sides. Once we do that, we should get x equals 8. Sure enough, this is our same solution as we got by graphing. Once again, so our solution would be x equals -2, and when x equals 8. Here we're going to be moving on to the kind of the demon of solving these quadratic equations. It's a little bit more complicated. It's called completing the square. First, I want you to take a look at what the standard form really is here of what a quadratic formula looks like. It's that ax squared plus bx plus c equals 0. We're going to be working with the example x squared minus 6x minus 16 equals 0. Let's move on to our first step. It's broken down into 4 to hopefully make it a little bit less complicated, hopefully make things go a little bit more smoother for you as you work through different examples. So as I said, that first step, it says move the constant c to the right side. We want to figure out what that c is. As we can see, our c is over here. We want to match that up over here. So it looks like a 16, but it'll actually be that negative 16. So we want to add that to the right side. So when we rewrite that, it should actually be x squared minus 6x equals 16. Moving on to our second step, it says take half the middle term. We'll pause it here and first do that. Half of our negative 6 would be a negative 3. Now moving on, it says we want to square it. So we're going to square that negative 3 term, which should actually equal 9, a positive 9. A negative 3 times a negative 3 is a positive 9. Now we want to add that result, that answer, to both sides of what our first step gave us. So when we rewrite that, that should equal x squared minus 6x plus 9 equals 16 plus 9. We can simplify that right side just a little bit. X squared minus 6x plus 9 equals 25. Now let's move on to our third step. The third step says factor that perfect square. Factor the perfect square. Now, the perfect square is really what's going to happen on that left side here. Our left side of what we did in step 2. The perfect square is going to happen right here when we factor. So now when we factor that, we should get x minus 3 times x minus 3 equals 25. So that's what we're talking about. That perfect square is that quantity itself times itself. We can actually rewrite this as saying x minus 3 squared equals 25. Finally, we can move on to our final step, which is taking the square root of each side. So when we take the square root of each side, so we're still taking that square root of each side. Now when we do that, we'll actually yield the result of x minus 3 equals 5. Now, just like how we did in the previous chapters that we've been learning about thus far this year, when we solve for an inequality, that method, we want to really apply that same method to what we're doing here. So we'll actually solve when x minus 3 equals a positive 5, and also when x minus 3 equals a negative 5. Here, when we solve that, on this left side, we should actually equal x equals 8. And over here, we should actually have x equals negative 2. So our solution would be when x equals a negative 2 and when x equals 8. So now we're moving on to this fourth way of solving quadratic equations, which is actually solving by the quadratic formula. You guys have maybe possibly seen this before. If you haven't, do not fret. We'll have plenty of time to work over this in class. So this is what our formula is for this quadratic, which is that x equals a negative b plus or minus the square root of b squared minus 4ac, all divided over 2 times a. Now we can recall a little bit that our regular form for our quadratic equations is that ax squared plus bx plus c, which is set equal to 0. Now that helps us pick out what our a, b, and c are for this example of 2x squared plus 7x minus 15. So here we can pick out our a, which is going to be 2, our b, which will actually be 7, and our c, which is actually going to be a negative 15. Now we can move on by substituting or plugging in our a, b, and c's into our quadratic formula. Here we can start right away by setting x equal to a minus 7 plus or minus the square root of 7 squared minus 4 times 2 times a negative 15. And this is all over 2 times 2. We can rewrite this a little bit here by simplifying and getting an x equals a negative 7 plus and minus the square root of 49. Now when you multiply out 4 times 2 times a negative 15, it should actually be a negative 120, but minus a negative actually turns into a positive, so it should be plus 120. All over 2 times 2 is 4. Now, when we simplify kind of what's happening here on the inside of our square root, we should actually get a x equals negative 7 plus or minus the square root of 169. Some of you might have the square root stuff memorized inside of your head. That's great. If not, don't worry about it. When we actually do this over, here we'll kind of shift over here on our board just a little bit. X should equal a negative 7 plus or minus the square root of 169 is actually 13 over 4. Now we want to split this up into two chunks a little bit here because of this plus and minus sign. So here our first chunk would actually be when x equals negative 7 plus 13 over 4, which actually would give us a positive 6 over 4, which actually reduces down to 3 over 2. And our other side here would be when x equals a negative 7 minus 13 over 4, which actually equals negative 20 over 4, which equals negative 5. So our solutions to this example would be when x equals 3 over 2 and when x equals negative 5. Finally, one of the problems that you might see on your assignment card and that we'll just kind of briefly go over a little bit is this thing called the discriminant. The discriminant here is this b squared minus 4ac. Now this looks familiar because that's kind of what was underneath that square root that we had in the quadratic equation. Now a lot of these problems that you'll encounter on your assignment card will say, find the discriminant of x squared minus 4x plus 15 equals 0, and describe the nature of the roots of the equation. So this is where we're tying into a little bit of that 4-1, that previous lesson we just learned. It then says solve the equation by using the quadratic equation. So here are some three things that we need to think about when we first find our discriminant. So we'll have a b squared minus 4ac is greater than 0, b squared minus 4ac equals 0, and a b squared minus 4ac is less than 0. So let's first start off here by picking out our, plugging in to our b squared minus 4ac. So if we look at our example here, our b would be that negative 4. So it should be a negative 4 squared minus 4a would be 1 when we look in front of that x squared. And then c would be a positive 15. Now when we do that, we can type that in and we would actually get 16